Hi there, Miss Barber here. The title of this lesson is Double Angle, Half Angle, and Product Sum Formulas. The learning objectives of this lesson are 1. Be able to use the double angle formulas to simplify trigonometric expressions. 2. Be able to use the half angle formulas to simplify trigonometric expressions. And 3. Be able to use the product sum formulas to simplify trigonometric expressions. The double angle formulas allow us to find the values of the trigonometric functions at 2x from their values at x. The half angle formulas relate the values of the trigonometric functions at 1/2 x to their values at x. And the product sum formulas relate products of sines and cosines to sums of sines and cosines. Roman numeral 1, the double angle formulas. For sine, sine of 2x is equal to 2 sine x cosine x. For cosine, there are several options. Cosine 2x is equal to cosine squared x minus sine squared x. It is also equal to 1 minus 2 sine squared x. And it is equal to 2 cosine squared x minus 1. For tangent, tan 2x is equal to 2 tan x divided by the quantity 1 minus tan squared x. If cosine x equals -3/5 and x is in quadrant 2, find cosine 2x and sine 2x. Let's begin with cosine 2x. Cosine 2x has several identities from which to choose. I'm going to choose 2 times cosine squared x minus 1. Then we continue to compute. 2, where the cosine is, we replace it with its value, which is -3/5. We square that, minus 1. The rest of it is arithmetic. So we will have 2 times -3 times -3 is 9. 5 times 5 is 25. Still minus 1. 18 divided by 25 minus, let's go ahead and get a common denominator for the 1. So it'll be 25 25ths. And performing the subtraction, we get that cosine 2x for cosine x equals -3/5 is -7 25ths. Let's continue with sine of 2x. If we've got sine 2x, that double angle formula has only one option, and that is 2 times sine x cosine x. Now we do have a value for cosine x, but we don't have one for sine, so we're going to have to use a fundamental trig identity to solve for x. For sine x, I'm going to use the Pythagorean identity and say that sine of x is the square root of 1 minus cosine squared x. Let's continue. Then we'll have the square root of 1 minus the value of cosine x is given in the statement of the problem. That's -3/5, and we square that. Now the rest of this is arithmetic, so we're going to have 1 minus -3/5 squared is 9 25ths. Get a common denominator of 25 over 25 for the number 1, and when you perform the subtraction, we're going to get the square root of 16 25ths, and when we finally solve for sine x, that value is 4/5. Now we can actually use the double angle formula to solve for the sine of 2x, and that is it's 2 times the sine x value we just computed, which is 4/5, times the cosine x, which we were given as -3/5. And we multiply across 2 times 4 times -3, 12 times 2, that's -24, and the denominator is 25ths. Write cosine 3x in terms of cosine x. We have a cosine 2x formula. We don't have a cosine 3x, so we're going to have to combine some things. The first thing that I'd like to do is separate the 3x into 2x plus x. Now we have the addition formula that can be used for cosine, and in so doing, we can write this as cosine of 2x times cosine of x minus sine 2x sine of x. Let's now use the double angle formulas, and so remember we're trying to get everything in terms of plain cosine x. So cosine 2x using a double angle formula, one of them is cosine squared x minus 1, and we still have cosine x. And then for the sine 2x, let's use the double angle formula for the sine, and we'll have 2 sine x cosine x. And remember to multiply the sine x that's already existed. Let's continue. Let's distribute the cosine x on the first set of terms, so we will have 2 cosine cubed x minus cosine x. On the next set, we have to be careful because we've got a negative and a sine x to distribute. So we'll have negative 2 sine squared x cosine x. I'm good with the 2 cosine cubed x. I'm good with the cosine x. In fact, I'm also good with 2 times cosine x. I'm using the commutative property to switch the order, and so it'll still be written as sine squared x. Now we'll continue, and I have 2 cosine cubed x minus cosine x minus 2 cosine x. Got to get rid of that sine squared, so let's use the Pythagorean identity and replace the sine squared x with 1 minus cosine squared x. Now let's continue to simplify, so we'll have 2 cosine cubed x minus cosine x. Let's distribute 2 cosine x to the term 1 minus cosine squared x, so we'll get 2 cosine x. Negative and negative gives me a positive 2, and then cosine cubed x. Now let's combine some like terms. We have a 2 cosine cubed x at the first term and 2 cosine cubed x for the fourth. We can combine those and we'll have 4 cosine cubed x. And then we can combine negative cosine x minus 2 times cosine x, and that'll give us minus 3 times cosine x. And now we expressed cosine 3x in terms of cosine x. Prove the identity. The quantity sine x plus cosine x squared equals 1 plus sine 2x. When we do identities, all your transformations need to occur on one side of the equal sign, and as a general rule, it's best to start with the more complicated side. So for this one, I'm going to begin with the left-hand side, and I'm going to expand the squared. So I will write sine x plus cosine x squared as sine x plus cosine x times sine x plus cosine x. Okay. Now we can multiply these two binomial terms. You might be familiar with using FOIL, F-O-I-L. I'll multiply the first terms together. So sine times sine gives me sine squared x. The inside terms and the outside terms are both sine x cosine x. So we have 2 of those plus 2 sine x cosine x, and the product of the last terms is plus cosine x. I'm going to change the order a little bit to make it a little bit clearer what I'm shooting for. So I'm going to write this as sine squared x using commutative property of addition. I'm going to switch the 2 sine x cosine x with a cosine squared x. So I'll have cosine squared x plus 2 sine x cosine x. Let's continue. Sine squared x plus cosine squared x is 1. And 2 sine x cosine x is the double angle formula for sine 2x. So now we transformed the expression on the left-hand side to make it match the expression on the right-hand side. Roman numeral 2, half angle formulas. The formulas for lowering powers allows us to write any trigonometric expression involving even powers of sine and cosine in terms of the first power of cosine only. The formulas for lowering powers. Sine squared x is equal to the quantity 1 minus cosine 2x divided by 2. Cosine squared x is equal to the quantity 1 plus cosine 2x divided by 2, and tan squared x is equal to the ratio of sine squared x over cosine squared x, which is 1 minus cosine 2x quantity divided by 1 plus cosine 2x quantity. Half angle formulas. The sine of u over 2 is equal to plus or minus the square root of 1 minus cosine u over 2. Cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine u over 2. And tan of u over 2 is equal to 1 minus cosine u over sine u, and it is also equal to sine u over the quantity 1 plus cosine u. The choice of the plus or minus sign depends on the quadrant in which u over 2 lies. Express sine to the fourth of x in terms of the first power of cosine. Lowering powers is a very important skill and a clever technique. Let's start with this. I'm going to rewrite sine to the fourth x as sine squared x sine squared x. I chose to do that because I actually do have formulas that will let me lower the sine squareds. So this I will replace with 1 minus cosine 2x divided by 2 times 1 minus cosine 2x divided by 2. Let's multiply. We're going to have to use the FOIL, first outside, inside, last, to multiply the 1 minus cosine 2x's. So we will have 1 minus, then we'll have negative cosine 2x minus cosine 2x, so that's 2 cosine 2x. And then the product of the last two terms will give us plus cosine squared 2x. And all of this be divided by 2 times 2, which is 4. Let's separate the terms. Then we would have 1/4 minus 2 over 4 we can replace with 1/2 cosine 2x plus, then we'll still have 1/4 cosine squared 2x. Now, our only issue is the last term, the cosine squared 2x. And we're going to change this, so let's note that I can change this using the power lowering formulas and write the cosine squared 2x, I'm writing this on the side, as 1 plus, and then we'll have cosine 2 of x over 2. And where the x was, we'll just put in 2x. Now we clean it up a little bit, and we get 1/4 minus 1/2 cosine 2x plus 1/4 times, and the cosine squared 2x can be replaced with 1 plus cosine 4x divided by 2. The 4x because we did the cosine of 2x. Now one final bits of cleanup, and we will have 1/4 minus 1/2 cosine of 2x. Then we have to be very careful because we're going to multiply the 1/4 through. So 1/4 times 1/2 is going to be plus, is that 1/8? Yep. And then we still have plus 1/8 cosine 4x. So the only thing left to do is add 1/4 and 1/8, which will give us, let's see, a common denominator of 8 for 1/4 would make it 2/8. So 3/8 minus 1/2 cosine of 2x plus 1/8 the cosine of 4x. And now we have expressed sine to the 4th of x in terms of the first power of cosine. Find the exact value of cosine of 15 degrees. Okay, this seems like a task for the half angle formula, so I'm going to go ahead and write that on the side so I have it as a reference. Know that the cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine u divided by 2, and the SIGN, that's whether it's plus or minus, depends on where u over 2 lies. So let's see, we'll start with the cosine of 15 degrees. I don't know an exact value for 15 degrees, but I do know the exact value for 30 degrees, so we can write 15 degrees as 30 over 2. Now let's fill in the parts to the formula, and this will be plus or minus the square root of 1 plus the cosine of 30 degrees divided by 2. Let's continue. This will be plus or minus the square root of 1 plus, and the cosine of 30 degrees is the beautiful square root of 3 over 2, and all of that over 2. Let's get that a little less messy looking, and so we can actually combine the terms in the numerator and simplify that, and we'll get plus or minus, and this can become 2, remember, because I'm going to do 1 as 2 over 2, so 2 plus the square root of 3, and then putting all of that and multiplying it over the 2 with the 2 will be 4. So we simplify it one more time, and we're going to have this as 2 plus the square root of 3, and the 4 in the denominator, we can take it out of the square root and write it as 1/2. Now we have to determine if it's going to be a plus or minus, and we know that 15 degrees is in quadrant 1, and all trig functions are positive in quadrant 1, so the exact value of cosine of 15 degrees is 1/2 of the square root of the quantity 2 plus the square root of 3. Find the sine x over 2 for cosine x equals negative 4/5 for x between 180 degrees and 270 degrees. So let's see, we need sine, the half angle formula, so this is going to be plus or minus the square root of 1 minus cosine x divided by 2. Let's put our numbers in. So this would become plus or minus, then you have 1 minus cosine of x is given as negative 4/5, And all of that is still over 2 and under the square root. Let's simplify some more. So we got plus or minus. Then 1 minus negative would be 1 plus 4/5. So 5 over 5 plus 4 over 5 is 9/5. And that is still all over 2. Clean that up a little bit more, and we get plus or minus the square root of 9 over 10. Now, we'll continue. So I'm going to have plus or minus. The square root of 9 is 3, and it's still over the square root of 10. Let's rationalize the denominator. So we'll multiply by square root of 10 over square root of 10. And that'll give us 3 times the square root of 10 over 10. Now, where do we decide, or how do we decide if this is positive or negative? If x is between, so if x is between 180 degrees and 270 degrees, that puts the x in the third quadrant where sign is definitely negative, but we're actually concerned with x over 2. So we know that then x over 2 would be between 90 degrees and 135 degrees, and in that interval the sign is positive, so sine of x over 2 for the given information is positive 3 times the square root of 10 divided by 10. Roman numeral 3, product sum formulas. Provided for you are the product to sum formulas and the sum to product formulas. These are quite extensive, and you will not be expected to memorize these 8 identities. Write cosine 9x plus cosine 2x as a product. So this would be a sum to product formula. The one that we're going to use is the one that says cosine x plus cosine y equals 2 times the cosine of the quantity x plus y, all divided by 2, times the cosine of the quantity x minus y, all divided by 2. Let's identify the parts. To find the cosine of 9x plus the cosine of 2x, let's follow the model of the formula. We'll do that by writing cosine 2 times the cosine of, and 9x corresponds to the x, plus 2x corresponds to the y, divided by 2, times the cosine of 9x corresponds to the x, minus 2x corresponds to the y, divided by 2. So the best that we can do is to write this as 2 times the cosine of 9x plus 2x is 11x divided by 2, times the cosine of 9x minus 2x is 7x divided by 2.